Hi everyone, that's me, Abdurrahman. Here's Adnan. Here's for the lab one assignment. So, in I'll be doing part B. In part B, we'll be doing we'll be performing basic arithmetic operations, the additions and subtraction on 32-bit double word operands, and we will observe how the values are stored and updated in registers and memory using this code debugger. And in part B, so it will perform a sequence of arithmetic operations on three double-word variables and stores the final result in the fourth variable. The operations are, which is move value 1, our first variable, into the EX register. We'll add value 2 to EX. We'll subtract value 3 from EX. We'll store the result in the final value. We'll call the dump bricks to display the contents of the CPU registers, and finally we'll exit the program. Here the data segment for the word, double word variables and the explanations from the video. So this one has value 1, value 2, value 3, and final value. As you can see here, each are, if you noticed, first three is initialized with hexadecimal value each, and the final value until now, because we still didn't start, is initialized, which you can see final value 000 is initialized and will be filled during the execution. So the three variables are defined as follows: value 1, the word 10,000 each; value 2, the word 40,000 each; value 3, the word 20,000 each; final value, the word still initialized, which is 0. As we said, each indicates hexadecimal, and we have a unknown value. If we open the memory right now, we'll have an unknown value because it's declared, as you can see, question mark, which is not initialized at a couple of time. It will only be given a value when the program executes the instruction that moves EX into the final value. So we have the code segment. Here's our algorithm. First, we'll move EX value 110,000 each hexadecimal to EX, and then we'll add EX value 2, which will be 10,000 each plus 40,000 each. Hold up, we'll show you right now. As you can see, 40,000 each in value 2. We'll add it so to be 50,000 each. In value 3, here it says 20,000. We'll move the algorithm right now. As you can see, in the red line is 30,000 each. Why is 30,000 hexadecimal? Because in the third step we subtracted the hex value 3, which from value 2, which was 50,000 hexadecimal. Now 50 minus 1,000 minus 30,000 each, it will be 20,000 each, it will be 30,000 each hexadecimal. And as you can see, it's moved to the final value, and it will display in the registers. As you can see, EX 30,000, EPX 32,000, as you can see. So uh, so now here you can see the in the watch one in memory. We'll see the memory. Let's see the final value. As you can see, the final value for in the memory location, and in this 189 ABCDF, and yeah, here's the memory locations, and here's the assembly. As you can see, new VX, value 1, value 2, value 3, final value, and the code down breaks, and finally the exit. As you can see, that if we go down, here's the new source file. We go up. So yeah, and yeah, here's the AutoZX 30,000, as we said correctly, and that was part B. Thank you so much, and now let's go for part C.
Hello everyone, I am Adnan and this is part C. And as we can see here, We are gonna start debugging first of all, like this, and then this is the watch. We're gonna add our variables one by one. One W1, and W2, and W3, and final val W. That's it. Then we are gonna add the other variables here, val B1, val B2, val B3, and final val B, like this. And also, we have here the register here, like this. Here the register, and then we are gonna add also our memory one, like this, and we will do it again. And also we have already our disassembly, and we still need the autos. The autos will do it. Autos, here is autos here. This is autos. Okay, let's begin filling our code. First of all, this is value. This is the value which are in word type, value one and value two and value three, with the final value also, which it is not initialized, but it is equal to zero. Then we have value. These values are in byte type, with they are initialized in 10, 40, 20. And final value in byte, which also uninitialized. We'll assign it later. So let's begin our code. We have this x, which is a variable parameter. We will move it to variable w1, which will be assigned as a 100. Also, we will add, and then we will add it to value two. It will become it will add it to 4,000, and it will become 5,000. Then subtract it from value three. Then which is we will subtract 2,000, and it will become the result, 3,000, as we can see in watch window here. Look on the debug. Final value down. Look how look, it become 3,000. Then we come to display registers. This is called the dump registers. We will to dump registers. So look to 3,000 here. Then we have this. We will. This is another for the other purpose operation. We will move all AL to variable B1. Start with a 10 hexadecimal. And then we will add it to variable 2, which is 40, and which will become 50. Then subtract it from variable 3, 20, which will become the result 30, as we can also see it in watch windows. Look here, here. It becomes 30. That's it. And then we will have our memory. We want to say, look, they are not initialized. We will search for our final value. The final value it's here. This is the value. And if we want to search for our value, w, this is also the location of our value, the final value, w, sorry. And here we have the AX register. As we can see, AX registers here, and our autos, we have this AX with the value of VB type unassigned also, and we will end the program. That's it. Thank you very much.